Any groups stuck on their calculators? Any groups not gotten it on your calculators yet? Yeah? When you go to your y equals, remember the a's become u's, which is second 7. A's become u's, which is second 7. And then the k's become n's, which are the variable button. Make sense? So how does this look, guys? Is that what you did? Ooh, good call. I was looking at it from over there and thought there was a negative. That's not right. Oh, it's frozen. There we go. Delete that guy, right? Okay. Now, second table. Yes. If it's automatically showing what's going on in my window, some of your windows might still be messed up, especially if you didn't use it yesterday. It's automatically generated starting at 0, going by 1s. You could have it starting at 1, going by 1s if you don't want to see the error. There's an error if you go up because remember, the n's are starting with 1, the first term, then 2, then 3, then 4, then 5. So, did you guys figure out the pattern? What was the pattern that this recursive formula was trying to show? Multiply by -2 every time, which is why your a sub 2 should have been -28. You guys keep going. A sub 3 is equal to positive 56. A sub 4 is equal to negative 112. A sub 5 is equal to 224. And that's exactly what the calculator just showed. Questions, Abby? You can do parentheses. Yeah, the calculator understands. And actually, you could have even just done -2 next to you, and I think it would have understood also. But good question, kiddo. Now, has anybody ever heard of the Fibonacci sequence? Oh. It is right there, but maybe some of you didn't realize. It's been on my wall the entire year. Now, question, does that look like a sequence? It's a lot of you, I mean, I would say no. It doesn't look like a sequence. It's a spiral, right? Question. Oh, seashell. That's a good place that you can find a spiral. Where else can you find a spiral? It's raining. There are lots of little things on the ground that I step on every time I try to take my dog for a walk. I was thinking snails, but there you go. That kind of spiral is a little a golden spiral, but that's the golden spiral. Staircase? Yeah. Cinnabon, there you go. Lollipops. Okay, hold on. Hold on. If you ever studied art, there'd be something called the golden ratio, and it talks about like how the ratios of the face should be set up and how some people think that Mona Lisa wasn't an actual person because the ratios, like the dimensions of her face are too perfect. Anyway, there's lots of interesting stuff about how artists used to do like the perfect faces, but they weren't very realistic, and so you start seeing them adding imperfections, etc., and that's when art started to become more real. But anyway, go watch Donald Duck in Math Magic Land. Coming back. Where do you see numbers up on that? Because there are numbers, right? Where do you see numbers? Okay, so you see some functions. That's at the very bottom, but that's just talking about the golden ratio kind of down below. Go up into the spiral itself. The spiral starts with a 1 by 1 square, right? Do you see it? Yeah. The very beginning of the spiral is a 1 by 1 square. And then it goes down to another 1 by 1 square. And then where does it go? What size square does it go next to? A 2 by 2, then a 3 by 3. And look at the 3 by 3. Isn't it the length of the 2 by 2 plus the 1? So it'd be 3 by 3. And then look at the next square. It'd be the 3 plus the 2, which would be 5. The next one would be the 3 plus the 5, which would be... What's the pattern of the Fibonacci sequence? So it's a recursive formula. We'll talk about in just 1 second. But every term needs how many prior? The 2. Now, some people say the Fibonacci starts at 0. Some people would say that. That's not really a thing in my mind, but some people would say it starts at 0. 0 plus 1 is 1. It's not totally wrong. But it does depend. Any term depends on the 2 prior. So instead of just establishing a sub 1, like most normal recursive sequences, instead of just having an initial term, the Fibonacci actually needs the first 2. So I need a sub 1 and I need a sub 2. And then if I establish a sub 1 and a sub 2, then question, starting at n equals 3, what would be the recursive formula? Okay, I see a couple. Lainey, start it. I'm going to stop you, and then we'll see if Nick can finish it. Okay, now stop. What else, Nick? Do you guys get that the subscripts are talking about which term? So if you're trying to get the third term, I need the third term. I need the 3 minus 1, the second term, plus the 3 minus 2 term. Now, get it in your calculator. See if you can get Fibonacci in there. The Fibonacci. Yeah. Change up your y equals in sequence mode. Let's see. It's a little bit different, but it's very, very similar. A's are still U's. K's are still N's. What are you talking about, Nick?
He was always partying. Right in the front seat.
The hardest part, I think, is going to be your U of n min. Because you don't just have one. I got it. Did you?
It only gives me one X.
Because the n min, well, the n min should be 1, but the U of n min, right? The first term, don't we need 2 first terms?
Yeah.
I only have one. No, I tried the comma.
How you do it? It doesn't work without the braces. So you might want to try the braces. It's second parenthesis. I know some of the newer calculators don't use the brace, so to be honest, I'm not exactly sure what you're supposed to do. But try the brace. Let's see if the brace works. Does the brace work?
Yeah, the brace works.
Does it work?
The
Oh, some of the newer ones actually have 2 different ones. You would just make them both 1. The newer calculators that have U1, U2? It might be because of Fibonacci. Just
Where's the comma?
comma's right above number 7. If you have one of the thin new ones, though, I think it has options for the first and the second. You're just going to put both of them as 1.
I never assumed that they should be a button for a comma. I thought it was going to be like a second or alpha.
Oh, yeah. Well, do you guys know why there's a button for the comma? It's actually pretty important. With programming, you use commas a lot. And so if you were to make an actual program for the calculator, they're trying to make things really accessible for the programming. There are some hidden functions, too, with programming, but the comma gets used a lot. And so it's like a set, kind of. Anyway. Okay. You want to see the Fibonacci?
What you don't know how sad that makes me. I've seen that. I've seen that video.
It's okay. SpongeBob might actually be living in a pineapple under the sea. The artist just drew it wrong. He needs to go visit him again. All right, so here we go. Factorials. We need to finish up section 9.1. We might see another Fibonacci video at some point because Fibonacci numbers are actually present in many, 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 many ways in nature. Maybe not the entire sequence, but numbers in the sequence, which is pretty interesting. Which is why I chose it for my wall with the golden spiral, with the quote, "Mathematics is the language with which God has written the universe." Some people like to say everything is chaos, and yet there's quite a lot of order. But talk to Mrs. Regan about that one. She can not debate, but talk through with some of you that might not necessarily believe the biblical account of creation, and she'll talk through many things that college professors would not. Because believe it or not, there's a lot of bias in our upper university education these days. You guys know what bias is, right? Not like bias tape. I mean, that's fun too. But bias as in having a predetermined worldview dictating how you see truth. Which, to some extent, I would totally say that I am biased as well, but I'm biased for the Bible, and that's what I hold my truth upon. But a lot of people like to say that they are rising above bias. They're rising above being limited in their worldview or being closed-minded, and yet university education is very biased these days. Just be careful. Anyway, life lesson, we need to talk about factorials. We need to talk about factorials. So, factorials. What does 0 mean? What's it mean? Yeah, I know. That'd be pretty rough right then. I won't mind. Okay. What is this? Exactly. It's a very excited N. It's a very, pronounced N. No. Factorial is the name for choop, 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 the little exclamation point when it is used in math. So this is not 0, it is not n, it is just n factorial. Oh, I know. An n factorial is technically defined to be, now some people would say, if I was to give you an example really quickly of, for instance, 5 factorial. All right. Some people would count down 5 times 4 times 3 times 2 times 1, and they would describe a factorial as, thank you, the product of all the numbers starting at whatever is in the factorial all the way down to 1. However, technically, we probably need to define factorials as counting up from 1 but ending at the highest number. Counting up from 1 but ending at the highest number. So even though 5 times 4 times 3 times 2 times 1 will be the exact same thing as 1 times 2 times 3 times 4 times 5, it might be better to think about it this way, and you'll see why. You'll see why. When we start getting variables in factorial and not just numbers. Because for instance, guys, how could we write n factorial if we don't know who n is? Can we actually start at n and literally count all the way down by ones? No. But we can start at 1 and then all the way up and then put a dot, 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 and say, but eventually it gets to, wait, who's this guy? Kind of recursive in the sense of -1 just means 1 before, right? If I'm counting by ones, if n is the highest, then the 1 directly before would be n minus 1. Yeah. The 1 directly before would be n minus 1. Now, really quickly, 0 factorial needs to be defined to be 1 because you guys would not understand. Like if you just look at it naturally, you'd be like, is it 0? Is it 1? Is it undefined? Is it not possible? We've done this before, kind of, if we have something like x to the 0. What do we say x to the 0 is? 1. Isn't that something you kind of just memorized? Now, there is some understanding to it. For instance, if you were to take like x to the 5th over x to the 5th, and if you use exponent rules, x to the 5 minus 5, maybe that gives you more of a reason as to why anything to the 0 is 1, because it would reduce. And there can sort of be an explanation for 0 factorial as well. It's just a bit more involved and a bit more complicated. But kind of like you guys have memorized anything to the 0 power besides 0, interestingly enough, is 1. We're going to memorize 0 factorial is 1. Now, here's a couple weird things, because factorials are kind of hard even when they're numbers, but when they're variables, they're even more difficult. Take a second and write down 2n factorial versus the quantity 2n factorial. There's a difference between 2n factorial and the quantity 2n factorial. Now, as you guys write it down, try to think through, what is the difference? They look really similar, right? But this one says go all the way up to n and then times 2. This one says go all the way up to, do you see the difference? Which one do you think is bigger? The top one or the bottom one? Let's do an example. If n equals 5. Okay, but think about it. Do you know why? If n equals 5, okay, shush. If n equals 5, 2 times 5 factorial. That would end up being, now, if you were actually to solve it out, it'd end up being 240. But you could also just write it and say, okay, it's going to be 1 times 2 times 3 times 4 times 5, right? 1 times 2 times 3 times 4 times 5. But what's going to be different with 2 times 5 factorial? What is that now? That's going to be 1 times 2 times 3 all the way up to 10. What's going to be bigger? 1 times 2 times 3 times 4 times 5 times 2, or 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. This one's just saying times 2 at the end. This one's saying, okay, let's multiply by a lot more numbers. And higher, getting higher and higher from the 5. So the one that's going to be stronger or greater is going to be this bottom one. But I just wanted to make sure that you guys understood. PEMDAS kind of still goes with factorials, meaning just like with exponents, remember how we would do the exponent first and then the multiplication? So 2x squared, who's getting squared? 2x squared.
X.
The x is getting squared, then times 2, right? It's not the 2 that's getting squared as well. So because the factorial is next to the n, but there's no grouping symbols, you would do the factorial first, then times 2, as opposed to doing the factorial up to 2n. Anyway, a lot of people would think the first one is greater for the very first time, and then they have to think about it in order to realize, no, the bottom one is actually greater. I do want us to play around with this. Yeah. What if you were given then a formula for a sequence that has a factorial? First of all, is this explicit or recursive? What kind of formula is it? Explicit or recursive? Yeah, explicit. It says go plug in n. Don't have to do a jumpity jump, just plug in. So to find the first term, what would my first term be? Ooh. Write down the formula. Write down the quick little note that says begin with n equals 0. Write down the formula. Write down the quick little note that says begin with n equals 0. Am I starting with a sub 1? No. What am I starting with? A sub 0. When you go to plug in, 2 to the, good, all over. Now, this is kind of nice because it's making you remember both of these, in a sense, defined answers. What's anything to the 0? Any non-zero to the 0? 1. And what's 0 factorial? Okay. So my first term is 1. But now we need to go ahead and get, what, the first 5 terms? Why am I only going to go up to a sub 4? Yeah, because 0 is a term, so I only need 4 more. Does that kind of make sense? I need 5 total, so since I started at 0, I'm going to be stopping at a sub 4. So if n does start at 0, it gets a little more complicated because whatever number you see, it's actually the n plus first term. It gets a little off because the first term is at 0, the third term is at 2, the fifth term is at 4. It gets a little confusing that way, but the math is still the same in the sense of you're just plugging in stuff. 2 squared all over 2 factorial, 2 cubed all over 3 factorial, 2 to the 4th over 4 factorial. Have you guys been solving this at all? What's 1 factorial? Sorry. It is 2 over, but what's 1 factorial alone? Just 1. You're like, but I start at 1 and end at 1. Yeah, okay, so it's 1. So 0 factorial is 1 and 1 factorial is 1. So I have 1, I have 2. What's 2 factorial? Okay, hold on. 2 squared is 4. I'm sorry, I'm asking about the denominators. 2 factorial is 2 times 1, and 2 times 1 would be 2, right? The final answer is 2. I'm asking if you know how to do the factorials. I apologize. 2 squared is 4. Good. 2 factorial is 2 times 1, or 1 times 2, which is 2. Now, yes, divide, it's 2. What's 2 cubed? I'm going piece by piece. 8. Good. 3 factorial is 1 times 2 times 3, or 3 times 2 times 1, which would be 6. 8 over 6 reduces to be 4/3. This is a weird sequence, yeah? Like 1, 2, 2, 4 thirds? Ugh. Just reducing. Jacob, what's up?
So what is the factorial exactly? Like how did you get 6?
Because factorials say, let me show it up to the side. 0 factorial is defined to be 1. 1 factorial, in a sense, is defined to be 1. 2 factorial is 1 times 2. 3 factorial would be 1 times 2 times 3. So what's 4 factorial going to be? 6 times 4, yeah. Or 1 times 2 times 3 times 4. So that's why I'm going to plug in over here 24, and 2 to the 4th is 4 and 4 is 16. 8 goes into 16 twice, 8 goes into 24 3 times. Now, how easy would it be to find the pattern in this formula? It'd be pretty hard. Like, this is nasty, right? Yeah. All sequences only get bigger or only get smaller, only get positive, only get more negative. But is there a clear formula that fills in the entire sequence? The answer is yes. Now, this is the type of sequence. Remember, 9-1 is a lot more than we have to go into depth in this year, right? Sequences in series, big topic, BC. This is one BC might have to deal with, but you guys will only have to like find terms from. You're just kind of learning how to read it. You're not really having to do much with it, which is nice. And they wouldn't ever give you a sequence this complicated for you to have to make up a formula to. Don't worry, that's not what you're going to need to have to do. Let's play with factorials just a little bit, though. Let's play with this just a little bit. 8 factorial over 5 factorial. 8 factorial, just start here. Don't go writing extra examples. Let's just work together. 8 factorial over 5 factorial. Some of you guys are starting to kind of work it, like write it out. 8 is 1 times 2 times 3 times 4. But question, how can I go really quickly and say, you know what, this isn't any big deal. It's just going to end up being 336. Eight minus 5 is 3, but that's not really going to be helpful. It's not a bad idea. He's trying to think of, wait a minute, I think maybe I can reduce something. And he's kind of right. Have you guys started writing it out?
Oh, wait.
There are no powers. Wait. Do you realize that 8 factorial has 5 factorial in it?
Okay, so,
But we can't go subtracting. We can't go subtracting, but what we can do is say, wait a minute, the 5 factorial can go away, and all that I have... Yeah, I don't know. Don't worry, don't worry. I did it right in my head. Okay. So what's 8 times 7? 56. And what's 56 times 6? 336. Yeah, I did not do 8 factorial in my head. Although I know that 6 is 720. I know that one. Because in BC we do a lot. So we have them memorized up to like 6, maybe 7. But wait, calculator. Is this a thing? Calculators can do this?
yes, they can.
Okay, now I don't want you to go to the math menu yet. I want you to just try to type it in. What if you were to type in 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 divided by 1 times 2 times 3 times 4 times 5? Wait, but that's wrong. So what happened? Calculator's dumb? If you do 1, let's see, can I actually do this? Times? Yeah, I can. 2 times 3 times 4 times 5 times 6 times 7 times 8. Okay? And then, times 8, I should have stopped. And then divided by 1 times 2 times 3 times 4.
That's an error.
I didn't get the right answer.
What went wrong?
It goes from left to right because they're all in the same.
Your calculator knows PEMDAS, and PEMDAS says multiplication and division, no big dealio, go from left to right. So it would do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Then it would divide by 2. Sorry, no, it would divide by 1. Then it would say, no, it doesn't know you mean divide by everybody. So if you wanted to divide by everybody, first of all, you would need to either put big old parentheses around this, or why not just use your really nifty make it a pretty fraction button, right? Yeah. Then if you do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, all over 1 times 2. Oh. Your calculator would need you to put this whole thing in parentheses or just write it in a nice fraction. However, does your calculator know how to do 8 divided by 5? Yes. Math. Prob. 4. Probability. Factorials are kind of important. Oh. So we could go ahead and actually do 8 factorial. Since 8 factorial is one quantity, we could just do a quick division because no PEMDAS errors will happen because it just has one quantity divided by another quantity. Math, prob for probability, which we won't see again until section 9.6 and 9.7. Got it. However, it will be useful for non-calculated portions of tests and just in general to be able to do some of these by hand. So can you guys use what I did to simplify? And can you simplify this a little bit without having to actually do all of 5 factorial, all of 2 factorial, all of 3 factorial, divide, multiply, etc.? What can I do? I could write it all the way out. I could do 1 times 2 times 3 times 4 times 5. All over 1 times 2 times 1 times 2 times 3. What happens to the 3 factorial? But can't I technically still keep going and then, I mean, the answer is 10, but, and you guys can do 20 over 2, but couldn't you technically have also reduced the 2 and the 4 to be 1 and 2? The 3 factorials canceled, and then the 2 and 4 can reduce. And why is that helpful? Because of letter C. Letter C, what do you think I'm going to try and cancel out with the numerator, the 4 or the 5 factorial? Yeah, because 5 factorial is in there, so why not cancel it out? If you guys are realizing, I can rewrite 8 factorial to be 5 factorial times 6 times 7 times 8. But don't I still have 1 times 2 times 3 times 4? So I can get rid of the 5 factorials. Now I still, wait. But why am I able to really quickly say this is 14? Isn't 2 times 4 the same thing as 8? And isn't 3 and 6 just 1 and 2? Huh, 2 and 7 is 14. Dun, 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 dun. The 5, 1, 2, 3, 4, 5, and the 1, 2, 3, 4, 5 reduce. 2 times 4 is 8. 3 and 6 becomes 1 and 2. Oh, it's just 14. Yeah, Nick. Yeah, you would have just had 5 and 6 and 7 and 8, and then you would have had to take the 5. Like, it's possible. It's just a little bit more work, if that makes sense. So you guys, ready, set, D, go. You can check with your calculator at the end, but see how well you can do with mental math. There's a lot that can reduce. Is it 21? I was thinking it's 42, but I did it mental math.
I think I wrote it, but I'm pretty sure I wrote it. Isn't it 6?
Oh yeah, I got 42.
What?
Yep, I got 42. It's the number 5. It's just 42.
42, I did it mental math. Go team.
Yeah, mental math. Hold on. I can't.
Oh, it's, yep, you're right. I missed it too. Sorry.
How is it 42? Okay, just explaining. I took away the 6 factorial. I took away the 6 factorial just because it's bigger and it gets rid of more stuff all at once. I saw that 2 times 5 is 10. I saw that 3 and 9 is 1 and 3, 4 and 8 is 1 and 2, 2 and 3 is 6, and 6 and 7 is 42. Now, why is this bottom one a whole nother different hard? Josh and Joe, shush. For letter E, n minus 2 factorial, all over n factorial. There's no numbers. I should have said there are no numbers, but either way, there are no numbers. Well, I mean, there are, but it's a variable. So do I know exactly when to stop for n? No. Well, I mean, I do. I know to stop at n. But why am I going to write n back here and show n minus 1 before that and show n minus 2 before that? Because one place before and one, yeah, because this one is going to up until, nope, sorry. I'm doing BC right now. N minus 2. Right? This one goes up to n minus 2. This one goes there, but it goes one more and one more. So therefore, what can I do? Remember, when you reduce, there's a 1 left, not a 0. And I get 1 over n minus 1 times n. Now, it's probably, that's kind of awkward way of writing it. Maybe this is a little bit nicer. Maybe the back of the book will actually distribute and say n squared minus n. Doesn't matter, either way. Even if they're variables, you can use the same idea of if there are any shared multiplications or any shared products, we can go ahead and reduce them. Ooh. Ooh. What have we reviewed so far? Pause. We have reviewed sequences so far. What was the second part of the title? Sequences and? Sequences and, Ryan, series. Question, what's the Greek letter? Sigma. Yeah, it's kind of cheating. Sigma. Question, what looks a lot easier, okay, looks a lot easier to write? All of these or that? All right, maybe. But if you learn how to write the Greek letter, it actually doesn't go that far or that long. It's pretty easy. You just do a little swoop, and then you just do a little whoop, whoop, and then you just do a little whoop, whoop. There you go. You do a swoop, and then you give it a bottom, and then you give it a top. Anyway, Greek sigmas have lower bounds and upper bounds. Now, there are properties of sums, and it is good and all. I don't think I necessarily want you guys to write down all those properties, so I'm going to just zoom in on the top. I would say, knowing that a series takes terms and adds them together, so it's like our entries with sequences, but instead of commas, what do we have now? We have additions. And those additions can be rewritten in one nice little sigma notation where it says, you know what, this is the same thing as this, because this notation says start at 1, start at plugging in 1 for I. And how does sigma work? What do you count by as you go up to n? Go by ones. So this notation says start here plugging in, and then plug in 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. Go however high you need to all the way to n. So then if you were given something like this, that's okay, this is good. This is a good place to end, and then homework will be due tomorrow. Don't worry, the last page, we're going to talk about it more in the future. If we were given something like this, we technically could pull the 3 out, but I'll show that in a second. We could do 3 times 1 plus, wait a minute, how do I know when to stop? I could do this forever, except, what does my sigma notation say? It's a 5. Stop at 5, which would have been the same thing as pulling out a 3 and just doing 1 plus 2 plus 3 plus 4 plus 5, which would probably be a lot easier way of doing it, because there is the property that the 3 can come out. But either way, you plug in starting at the bottom, and you go all the way counting by ones to the top, and then you solve. Is there a button in your calculator that can help you do this? Yes, if it's on the calculator portion. This one would be instead, guys, where would you start plugging in for this one? Says start at 3, so fine, I'll plug in and start at 3, then put a plus. What would be next? 1 plus? Then what would be next? And when do I stop? Never. When it says stop.
6. Oh, okay.
And then you solve. Homework 9-1, due tomorrow, sequences and series. I'll see you guys later, Gators. Stay dry, stay healthy. Praying for you, buddy. Bye.